Thank you, sir. Now I request our honorable chancellor, Shri Rakesh Singh Rathod, sir, to give this word gathering with. Sir, please.
आज विक्रांत सभागार में शिक्षक विकास कार्यक्रम सुबह से ही आयोजित किया जा रहा है, 6 दिवसीय है। मैं सबसे पहले क्षमा चाहता हूँ कि प्रारंभिक सत्र में मैं नहीं आ पाया। डॉक्टर जी के व्याख्यान से मैं वंचित रह गया, लेकिन सौभाग्य के विषय है इंजीनियर सचिन अग्रवाल, इनका व्याख्यान सुनने को मिलेगा। दोस्तों, शिक्षक तो दीप की हड्डी होती है किसी भी समाज की, और आज इसकी आवश्यकता क्यों पड़ती है? फैकल्टी डेवलपमेंट आवश्यकता हमेशा इसलिए पड़ती है कि नित्य नए प्रयोग होते रहते हैं, तकनीकी वैसी परिवर्तन होते रहते हैं, और ऐसी स्थिति में आपके शिक्षकीय पेशेवर कौशल बढ़ता रहे, इसके लिए भारत सरकार प्रयास की जाता है कि आप शिक्षा वाली सब्जेक्ट आज जो विषय हमारे पाठ्यक्रम की इस कार्यशाला वो इंडस्ट्री 5.0 ओपन की एक मैं अभी चिंता कर रहा था हमारे मित्र से। मेरा जब जन्म हुआ तो इंडस्ट्री शायद 0 रखी या 1, और मेरे जीवन काल में 5 के साथ कितना विकास हुआ, कितना बौद्धिक क्षमताओं में विकास हुआ, यह जो है मार्गदर्शक होता है। पहले दूसरे को इस अवसर पर मैं सबसे अनुरोध ये करना चाहूंगा कि युवा पीढ़ी जो कि इंडस्ट्री 1 से परिचित नहीं थी, तो उसकी कल्पनाओं में, तो ऐसी स्थिति में जब भी हम शिक्षण प्रणाली को नई पीढ़ी में इनकलकेट करने का प्रयास करते हैं, तो ऐसे में तो भारतीय मूल्य परंपरा का जरूर समावेशी सिद्धांत के तौर पर शिक्षण प्रणाली में लिया जाए, क्योंकि हमारे संस्कार मौलिक रूप से वो बने, और इसके अंतर्गत तो होता क्या है कि हमारे रचनात्मक छात्रों और और है, जिसमें आलोचनात्मक चिंतन, अन्यथा क्या होता है कि हम थोड़ी सी आलोचना से घबराते हैं। तो आलोचनात्मक चिंतन हमारी शिक्षण प्रणाली का ही बड़ा अभिन्न अंग है, प्रमुख मुद्दा है। सृजनात्मकता रचनात्मकता हमारे यहाँ नवाचार के रूप में तमाम चीजें आ रही है, चर्चा भी होगी आपके साथ, लेकिन आलोचनात्मक चिंतन और समस्या समाधान की क्षमता विकसित करने में आज की कार्यशाला या आज का 6 दिवसीय जीवन करने वाली ये कार्यशाला, इसमें शिक्षक आज कार्यक्रम नाम दिया जरूर गया है, इंडस्ट्री 5.0 का नाम भले ही दिया गया, लेकिन इस पर जरूर परिचर्चा और चर्चाएं हों। ऐसे माध्यम होते हैं, ऐसे मंच होते हैं जहाँ की युवा पीढ़ी जो कल का कर्णधार है, भारत का भी विश्व का, इसका सर्वांगीण विकास हो, न केवल पुस्तकीय ज्ञान से, ये ओतप्रोत हो, व्यवहारिक ज्ञान से भी। मुझे पूरी उम्मीद है कि विभिन्न महाविद्यालयों से पधारे हमारे शिक्षक दक्षता के साथ अपने अपने कर्तव्यों का निर्वहन कर रहे होंगे। थोड़ा सा अनुरोध यही है कि युवा पीढ़ी को साहसी और समस्या का समाधान करने लायक क्षमता विकसित करने का उद्देश्य जरूर समाहित करें इसमें, और आपके ये 6 दिवसीय निरंतर चलने वाले विकास कार्यक्रम है, इसके अंत में मुझे विश्वास है कि कुछ न कुछ शैक्षिक कौशल का विकास ही होगा और ये विकास नई पीढ़ी में इन्हीं शब्दों के साथ आप सभी का पुनः बहुत बहुत अभिवादन करता हूँ, स्वागत भी करता हूँ और अग्रिम पंक्ति में बैठे हमारे मुख्य वक्ता हैं आज के, इनका भी बहुत स्वागत करता हूँ और आप सभी के लिए शुभकामनाएं प्रेषित करते हुए अपने विराम देता हूँ। जय भारत, जय हिंद।
Thank you so much, sir. Now I'm really honored and it's a pleasure to introduce Engineer Sachin Agrawal, sir, Executive Vice President and Head of R&D and Technology, Volvo Eicher Commercial Vehicles. He is leading and guiding motivated team of 800 plus engineers involved in complete trucks and bus range development for Eicher and Volvo vehicles powered in electromobility and hydrogen mobility, connected solutions and embedded software, advanced technology development, virtual validation, and vehicle engineering. He is a member of executive management of Volvo Eicher JV and has developed state-of-the-art ESBI combine diesel and CNG product range in-house. He has extensive exposure working in multi-location environment, collaborating collaboration with Volvo on technology transfer. Postgraduate in design engineering from IIT Bombay. Mr. Agrawal, sir has also been US Fulbright scholar and has completed fellowship for leadership and management from Carnegie Mellon University, Pittsburgh, USA. He is chairman of Frontier Technology and Innovation Group of Society of Indian Automotive Manufacturer SIAM. Sir, welcome you to take us forward so you will enlighten us with future trends and challenges in implementing Industry 5.0 technology. Sir, please.
हमारे जो आज की जनरेशन है, लोगों को सीधा हम इंडस्ट्री 5.0 पढ़ाने वाले हैं कि 5.0 जबकि इम्पोर्टेंट है इंडस्ट्री 1.0 होना चाहिए, 2.0 होना चाहिए। मैन्युफैक्चरिंग है वो होना चाहिए, मास मैन्युफैक्चरिंग क्या होता है वो पता होना चाहिए। जैसे हम उसमें IoT क्या और इसको कैसे इंटीग्रेट करते हैं वो पता होना चाहिए। All these things are very important before the students or the investment W are faculty colleges or universities. Same here. Important that when you are preparing your students, please first train them on what is industry does, specifically or actually talking about industry or industry. And I promote industry more and science together because there is not much difference between industry or industry. Industry and other Yes, because how and human can work together. So you have seen 1 to 3 was primarily it was based on how human can work. From 3 onwards, actually private project coming in, industry more than it became more and more focused on side that how can we have automation, how can we have IoT, good type of things. And industry while actually we are going back. We are going back and we are seeing how very well accepted. When you talk about human intervention, that was nothing but going back. जैसे मतलब अच्छा होता है भी कहीं कहीं आ जाते हैं पहले वो तुम आ जाते हैं सीधा एक तो हो रहा है सीधा चीजें रिलेटेड तो तो दिस इंडस्ट्री ह्यूमन का इम्पोर्टेंस बढ़ रहा है तो हम धीरे से लेके आ गए मुझे मशीन और ह्यूमन साथ में काम करें मशीन और ह्यूमन साथ में काम करेंगे तो मतलब क्या है हमें समझ में आ गया हम इंडस्ट्री 2.0 हम बात कर रहे थे तो हम क्या बोल रहे थे एक समय आएगा तो ह्यूमन हट जाएंगे पूरा रोबोट होता है कि अंडरस्टूड कि रोबोट्स कैन नॉट वर्क ऑन इट्स AI cannot work on it. You need human. Now we have started talking of we have given some fancy names, smart management, one-sided, the cognitive management, all those things are there. But ultimately, it's good for. So whatever my actually graduate focused on industry perspective, many of during water and very various course type of really doing work very not be but I think it is quite difficult for the and what are the of this project that is the biggest side these slides are just part of the these slides are not the right just right connect with that's not part of part that is just some perspective so hang on certain yeah of course but not the right what we have understood that only we have to grow and this basic concept of it so that some knowledge is going to be one should define what can be what should be done. That should be covered with when you keep here we are why this is important for us to question here. So India is a growth story. They are now both largest economy for 2020 one behind one and the rest of us and will be ahead of will become world largest economy. There is no US dollar here. Confirmation. Here it is 5% growth. Area. But import is standard. It is not using not वीडियो को सेंसिटिव किसी बता ले रिसीवर से जाऊं ठीक है ठीक है। So, these are the three sectors where we have major challenges in terms of growth. Agriculture sector growth is more or less stagnant, and if you see government focus today, the agriculture sector has reached to that level where you have grow beyond by natural resources that we consume in terms of food. By that way, agriculture sector cannot increase much. So now government focuses more that how to use agricultural products into industry and how they can use it mainly by generating energy. See, why we need food? We need food to make energy for us, ourselves. Same way, this food what we produce can be converted into energy that can be used for running a bus, running a car, running an aeroplane. So all these things are basically running by energy. It's always possible to use this energy generated from the fuel. So we can see that we are third largest startup ecosystem. Uh, we have a huge population, and having huge population also means that we have very big base to consume. We have a big consumer base and extremely high focus of government on it. Almost 30 to 40 kilometers per day. So why I am giving all this context is that with all this context, agriculture, manufacturing, service, doesn't need any help. That means very good. That sector, agriculture, for agriculture, government is doing a lot of things. They are pushing industry and how agriculture produce more and more. But to practice manufacturing is in our kind of say and teach them in leaders have to learn that practical thing so that when they come and they should share you and you know that they and how to get move of that. This will be the only objective for guide the students who are getting who are getting. So this because more from the audience side, you can see that our GDP growth is very good. And India is second largest manufacturer of offices in the world and fourth largest manufacturer of India is fourth largest manufacturer of vehicles, that is cars, is second largest manufacturer of scooters and largest manufacturer of chips. You can understand that what is the type of energy in the world. Yes, they are producing but on the energy. That is the type of contribution And in this project, that see the adventure of emission. So this is about it. So in an adventure, was formed around that. 2 years back, we celebrated our 15 years of partnership. And Volvo is already the key and at least request the third party segment of our emission. And which we only got very on the Indian market. So this is very, I would say, it is a type of joint venture where both of us support each other in our strong. These are our business areas. We make action person buses, we make Volvo trucks, we make Volvo buses. We have Eicher engineering components, wherein we produce transmission and axles and several other aggregates for some of the world's best things like here, the cars, for all these things we make big axles. Then we have Eicher power solutions, wherein we make assets. We
also make engines for the cranes. For example, all these escort cranes or ace cranes, all these cranes are equipped with Eicher engines. And then we have VE powertrain. So this VE powertrain is basically a center where we make medium duty engines for global requirement of Volvo. So it includes markets like US, Europe, everywhere we export these engines. This is a very congested slide, and the purpose of showing this slide is I am not expecting that you should know the complete product range or the variety. Purpose is to just to show you that how complex today's industry is becoming. So if you see our complete automotive industry, Eicher is only one small part of it. First of all, you see the complete manufacturing industry. Then you see the yeah, so correct. This will work. If I put it here, this will work. Okay. So Eicher is only a small part of automotive industry, but within Eicher, if you see, this is the variety that we have to handle. You can see that what type of variety we are producing. We have various platforms, Pro 2000, 3000, 6000. This is only light and medium duty trucks, heavy duty trucks. There itself we have so much of variety. Then we have tippers, we have haulage, we have tractors, then we have buses, then we have diesel, we have CNG, we have hydrogen, we have LNG, we have electric. So many varieties there. Then you come to various configurations. Starting with cargo body, deck length, the truck का जो body होता है जिसमें सामान रखते हैं, it starts from 8 feet, 10 feet, 11 feet, 12 feet, it goes up to 33 feet like this. Almost every 1 to 2 feet we have one variety of cargo body. Then we produce tippers. There again we start with 2.8 cubic meter, we go up to 33 cubic meter now. Then our smallest vehicle now is 2.6 ton GVW. It goes up to 55 ton GVW, and almost every half a ton of GVW difference, we have one truck model. So similarly bus, every 4 seat difference we have one bus. We have starting with 12-seater, 17-seater, 22-seater, 26, 28, 31, 35, 39, 45, so many variety up to going up to 62-seater buses. We have so many variety of buses that we have to produce. Then we come to the aggregates, engines. We start with 2-liter engine, we go up to 8-liter engine. We have 2-liter, 3-liter, 3.3 liter, 3.8 liter, 5.1 liter, 7.7 liter. These are the engine variety. Then again in engine we have diesel, CNG, LNG, all types of engine, and slowly we are going to migrate towards hydrogen. So this is the variety, this is the umbrella that our manufacturing team has to handle. And over and above this, we keep on adding variety. Like for example, this year we have added now this one new product. Now this new product is what? This is complete SCV product range. It is going to have 2.6 ton, 3 ton, 3.5 ton, again EV, diesel and CNG, different segment, e-commerce, parcel courier, food and vegetable, cold chain, white goods, all these segment, total 54 applications. Now simply this variety is added into complete product portfolio. Now with all this happening, expectation is that our volume should keep on increasing. Why we are doing all this? We are doing this to increase our volume, to ensure that we gain market share, we increase our profitability, and this you can see, this is the volume growth path of ECV. 2020 is the time when we had COVID. Before that, industry was on the peak. 2018-19 was the time when industry was on the peak. Commercial vehicle industry in 18-19 was 1 million, 10 lakh vehicle, and Eicher was 72,000, 73,000 broadly that year. Now after COVID, FY25 last year that got completed, industry size has not reached to 1 million vehicle. It is still around 900,000 vehicles, commercial vehicle. But Eicher has increased from 73,000 to 90,000. So while industry size has reduced, Eicher has increased by almost 20%. Why this has happened? It is anybody's guess, because we are bringing more and more product, we are going close to the customer, we are making the product which is suitable to customer. And this is one very important element of Industry 5.0, that is mass customization. So all of you would be aware about this. Theoretically, all of you would be aware. Practically, I wanted to explain you that what is mass customization. As many segments, as many applications you can reach to, it is going to help you to gain your volumes, your numbers. And this is going to happen only with the help of how flexible or how resilient your manufacturing setup is. Unless your manufacturing setup is not able to handle variety, you cannot gain market share, you cannot increase your volume. See, if you buy a water bottle, it might cost you 500 rupees. Same water bottle, if you go and tell that I want my name written on it, say if I say that I want Sachin to be written on that water bottle, that 500 rupees water bottle will become say 800 rupees water bottle. So customization always adds value to the product. And more the way young generation is migrating to a thought process where they want that thing should be specifically made for them. With that thinking, it is becoming more prominent that you add customization into your manufacturing setup. So this growth, I would say that it can be attributed to the capability of ECV to handle this type of customization. This I can skip this, and so when we talk of product and technology development, so we have a very strong 800 members team who works on various areas, and it includes a lot of virtual tools, virtual reality, lot of computational fluid dynamics, lot of testing, physical testing. You can see all the structural testing, reliability testing, durability testing. Complete truck can be tested on a rig. So we call it 4-poster, wherein we mount the complete truck onto the 4 post and run the actual duty cycle, which is going to be loaded in physical duties. Then we have working on future technologies. So diesel is something which we are working on today. Then we have biodiesel, CNG, LNG, which are produced in market. Electromobility is where we already have started seeing some numbers coming. And hydrogen is technology for the future. Hydrogen is highly flammable fuel, but we see that this technology has also started gaining some ground in the Indian commercial vehicle industry. So like we have Industry 5.0 for manufacturing, it is very important to integrate our manufacturing process with new product introduction process. So this what you see here is R&D 30, we call it R&D 30 process. Basically R&D 30, we gave this name to it because we wanted to reduce everything by 30%. So 30% reduction in time, 30% reduction in cost, 30% reduction in resources. How it happens is by increasing the efficiency. So this R&D 30 process is where we closely link all our industrialization area with our product development area. So all the elements of industrialization starting from concept development till final industrialization and start of production. All these phases are linked with our R&D 30 process. Innovation, another very important part of Industry 5.0. So it is very critical area, and you can see that we have very extremely high focus on innovation in VCV, and we have generated close to 12,000 areas. Around 12,500 ideas. So I have been given a chit, and I am getting corrected here that there are some participants from industry also. So thank you very much for this, because I thought all are faculty. तो अच्छा है कुछ industry वाले लोग हैं तो they can appreciate more. So here I would say that now I will go to the core topic of manufacturing and how we are deploying Industry 5.0 into various manufacturing setups. So this is our VCV manufacturing facility. We have around 32,000 direct and indirect employees. We are, as I shared earlier, that we are global supplier of BS6 engine. We have total 8 plants in India, 7 in Madhya Pradesh and 1 in Karnataka, Bangalore, for Volvo truck, and Volvo bus. So these are our 8 plant locations. And in Madhya Pradesh, we are primarily focused on 2 locations. One is in Indore and second is Bhopal. So these are the 2 primary locations where we are based at. So if we see, this is our mother plant, truck plant, which was commissioned in 1984. This is a small plant, only spread 80-acre land. So considering the type of production that they take from this plant, it is a small plant, and this has the capacity of 90,000 trucks and buses. So this is probably one of the highest per acre production capacity plant in the world from commercial vehicles perspective. And here we can produce everything 5 ton to 55 ton, only the smaller trucks we cannot produce here. And this plant is driving all the green manufacturing, BPS and Industry 4.0 in our different plants. This is our new plant, Bhopal plant. So this is slightly bigger. This is 148-acre plant with only 40,000 capacity, which is commissioned as of now. But this has capability of extending up to 80,000. And here we produce small commercial vehicle, electric vehicles and medium duty vehicles. And here we are driving green manufacturing and sustainability. Then we have a bus plant in Bagad. So this is specifically made only for the bus body, and this can produce as many as 12,000 buses in a year. Then Volvo bus plant in Housecourt, where we in Bangalore, where we produce Volvo branded buses. And this plant has lower capacity. It is a small plant, 25-acre plant. We produce around 1,000 buses in a year, and a lot of it gets exported to countries like South Africa, Europe, and other countries. Then this is powertrain plant, wherein we produce engines for the European market. Now you have to see this slide carefully. Earlier I have shown you one slide that what is our product range. Now you see that how this product range has to be converted into industrial strategy, manufacturing strategy. So this is something which is talking about manufacturing strategy based on your product range, how to fulfill complete product range, ensuring that all your facilities are utilized properly. Quality, maintaining quality is also very important. So this is the area where we want that it should be customer satisfaction India number one, and we should be able to deliver products with zero irritants, and initial customer experience should be delightful. So that is the motive with which we produce. We have all our industrial setup. These are some of the areas where we focus today. So while we talk of Industry 5.0, we do not work on everything of Industry 5.0, but we have these three focus areas from Industry 5.0 perspective. First is Volvo production system is nothing but again Industry 1, 2, 3. Very basic thing. If you will see here, you can read. It is as simple thing: people management, performance management, basic improvements, just in time. Those type of things are important areas in Volvo production system. What type of quality is built in when you produce? So these are the things which are important here. And when we go to further, when we go to further, then we say that IoT industrialization, how it can help into our manufacturing efficiency enhancement, how to make our manufacturing system, industry system future ready. So there we have a lot of focus. I will cover these areas more into detail. But primary focus is that we have cost and productivity in our mind. And third very important area is sustainability, which is the need of hour. If we have to, all of us want to give a healthy life to our next generation, and if we want to do that, it is our responsibility to ensure that whatever we do it sustainable. So that is where our high focus is there on sustainability in manufacturing. So coming to few slides on Industry 5.0, and then I will connect that how some of these things we are deploying in Eicher in some details. So as I explained, Industry 5.0, the only thing it changes from 4.0 is that it says that man and machine should be interconnected, and there should be increasing customization. And all this is required to handle more and more complexity that is coming into manufacturing. We feel that it is likely to affect all three: economy, ecology, and also the social world. There are a lot of strategies, tools which are being worked on in Industry 5.0, through which we can reduce wastage of material. And in fact, a new terminology which all of us are talking now is how to migrate towards zero waste production. And as I was sharing in initial part of my talk, that while earlier we were talking more of robots. Earlier it was, first of all, it was human, then robot, but now it is more of human-machine collaboration. So that all the repetitive things can be shifted to robots, but at the same time all the creative thing continues to be with human. And why this is becoming more important is that if you see today in India, getting labor is comparatively easy as of now. But in some of the niche areas, for example, drivers for tippers. Tippers means mining trucks. It is very difficult. You will be surprised to know that 100% of mining tippers, they are all air conditioned. And why they are made air conditioned is because they do not get drivers. You have to provide extremely high level of comfort to driver, then only driver will come. You can imagine that how much a driver of tipper must be earning. They earn close to 70 to 80,000 rupees per month. But still, if you ask anyone that whether he would like his son to become driver, he will say no. Because these are basically tough tasks. So today, while in India we are in that scenario in 2025 where we are able to get labor easily. In Europe, if you go, that one driver salary is 1 crore in a year. In India, probably it is 5 lakh to 10 lakh maximum. In 5 to 7 years, you will not get labor easily. Yesterday there was one article in one of the newspaper that while unemployment in Indore has increased by 20%, but at the same time, 1 in 3 industry, means 33% industries in Indore area are struggling for the lack of labor availability. Now, on one hand, unemployment is increasing, on the other hand, we are not getting labor. Why it is so? Because today's generation, they do not want to work with their hand. They only want to work on mobile, laptop, computers. So that is the area where they want to work. So the essence of Industry 5.0 is that where work is more repetitive, work is more laborious, work is more mechanical, it can be done by robots. But where we need creativity, brain, mind, that all can be done by humans. Today I was reading Economic Times and their CEO of Mindtree, he has written that all the recruitment for future will be for engineers who can value add over AI. So they use AI, but they add their creativity over AI. So that is going to be the future for our engineers. And here you can see that while we talk of fifth evolution of industrial practices, from simple mechanization to mass production to computer aided, then cyber, we are going to now more of cognitive systems. So these are the three core pillars of Industry 5.0. First is human-centric approach. Second is focus on sustainability. And third is resilience. So resilience, once again, I will say that I am a big fan of it, that as much flexibility, as much customization you can bring into your industrial setup. This is the best thing to happen for any industry. Sustainability, all of us know that it is important and it will become more and more important going forward. And the human-centric approach I already talked about. So why it matters? It bridges technology and humanity because it puts humans at the core of industrial value creation. It helps into customization and mass personalization. It supports sustainable goals, industrial growth, and it cultivates and boosts innovation by combining human creativity with smart innovation and AI. What are the technologies that are going to enable Industry 5.0? So, first of all, it is very important for sustainability perspective that we have bio-inspired material and sustainable materials which can be recyclable, it should be lightweight, it should be self-repairing. So those are the basic things which are very important. Human-machine interaction has to increase, so there can be many things. Augmented reality is one very important area. Even tracking of physical stress. So, like you will see that most of the, again taking example of same application tippers, 100% of the tippers that we produce, we have a device called driver drowsiness detection system. Driver drowsiness detection system. So every tipper has got a this device installed, and as soon as driver is feeling drowsiness, we keep on monitoring his eyes movement, and as soon as we feel or that system feels that he is feeling drowsy, it will give an alarm. It will give an alarm, or even it is not only drowsiness. If he starts talking on mobile, it will give an alarm. Reason is that if you see that application is very I would say it is bit of risky driving, wherein you are driving into mines, and if you are not fully alert, it can lead to accidents. So, this is just one example of tracking employees' physical or mental stress level. Cobots, I think all of you know all these robots that work in collaboration with human. So that is another area which is very important from human-machine interaction perspective. Digital twin is another very important thing because you cannot do everything physical today. So it is very important that you have virtual simulation of products, virtual simulation of processes, then you model them, then you run various type of experiment what you want to run on those digital twins, and based on that digital twin output, you can then implement some of these results to physical world. So it is basically, you can see here on the small sketch that is made, that it is basically integration of physical world and virtual world that has to be combined together to get higher efficiencies. What are the future trends? So on all the four areas, human-machine collaboration, I think the future trend is going to be on the advanced cobots which are going to come in the industry. Then on production and mass customization, lot of data-driven insights and flexible manufacturing. Then sustainable manufacturing, net zero operations, green energy, supply chain efficiency. So all these things are very important, and then emerging technology has to be integrated. All these things, 5G, edge computing, quantum computing. Let me tell you, IT will become a major enabler for industry. And it is very important that all manufacturing engineers should learn more and more IT related technologies, because that is where the future will be. So on robotics, I think again now I have few slides, but as I shared earlier also, I am not an expert into robotics, so these are just to only share that what are the areas where we should actually focus from future industrialization perspective. So all these industrial arm robots, all of you I think know it very well. All this 6-axis arm, now we have that 7-axis arm also with one additional linear movement. Then we have Skara robots, Delta robots, Spider robots. All these robots, I think this we have been using in industry 4.0 last few years now. What is going to come new is now collaborative robots. I would not say it is completely new, but in industry, yes, it is now slowly coming, and it is a major challenge to even train and groom our engineers and staff to work with robot. It is not so easy, because in this concept, our employees are supposed to work along with robots. So it is one difficult thing, and then a lot of software robots which all of us face in day-to-day, whether it is in banking industry and other areas, where we have a lot of software robots who are working. So these are some slides, you can read it through, I will not mention. So this is 6-axis robotic arm, you can read it if you want. Then we have Skara robots. Skara is selective compliant assembly robot arm. This is basically the main purpose of this robot is to use in some of the application where you want to dispense some specific quantity. Load requirement is less, number of axis requirement is less, only 3 to 4 axis, and it is speed wise it is high speed as compared to 6-axis robot. Then we have Delta robot, which is basically 3 arm. If you add one more 4 arm, it becomes a Spider robot. And this is one of the fastest growing robot in industrial setup, because lot of focus is coming on manufacturing of semiconductors and manufacturing of PCBs. So there this robot gets very high utilization, and here again load capacities are very small, but it is very high speed. Then we come to the collaborative robot, and you can see that how you work with collaborative robot. So here actually part of work is done by robot, part of work is done by human together. They are very flexible robot. Basically they can do some part of work, so you can use them into multiple applications. Most of the industrial robots are SPM, special purpose machines, whereas these are more generalistic type of robots, where you can utilize them in multiple operations based on need. And they are very small, lightweight. You can easily move them, you can easily program them, or even you can hand train. Hand train means that you push the training button, you move the arm as you want to move it. So first time you do this activity, instead of you doing, you make that robot to do that activity. Now many of you would have seen the house cleaning robots. Some of you have seen those round house cleaning robots. So like you train them first, and then they will keep on doing the same work again and again. So similarly these robots are also there, where you just train them once and then they will keep on doing. So they are very simple to use. The only challenge is, you can see this lady is still able to work, but in our experience it is not so easy for humans to work with robot. So this is one major challenge for working them. So this, I would say, the major thing where today we are working on using this is that how do we upskill our workforce so that they gain skills to supervise and program and maintain these robots. Then ultimately these are robots, so we have to also take care of safety. So we have to ensure that we have built-in sensors and controls, so that we have good smart human and robot interaction, and it should definitely help into flexible manufacturing and also enhance our productivity and personalization. One positive aspect of it is that once employees are comfortable dealing with robots, their fear that their job will be job may go because of these robots, that is not there, because they know that this fellow cannot work independently. This fellow will need my help to work. So my job is intact. So that is one positive thing with all these robots. Then mass customization, I have talked about this, various technologies which are there to make smart, flexible and automated systems with human creativity. So Industry 5.0, it enables to deliver personalized products at scale. So I will just give one example that today if you go to any car market, car dealer, they will always give you an option that you can select this color, you can select this suspension, you can select this feature, you can select this transmission, you can select this power. Many features they ask you to combine together. How do they handle all this in manufacturing? That is only through various digital interfaces that we create, through which you can co-create, co-design product. And then advanced manufacturing can handle such small batch variations efficiently. Then a lot of help is taken through digital twins, and we have to also ensure that when we do this mass customization, we fulfill these unique needs without very high cost. And this definitely enhances customer satisfaction and loyalty, because then customer feels that it is something which is getting created for me personally. So three important things here: harnessing the power of digitalization. So using various digital technologies, AI, digital twins, IoT, then human-centric production. So again here collaborative robotics is the key enabler. And then you should have high versatility in your manufacturing system through flexible manufacturing system. So when we talk of sustainability, all of us know that it means we have to minimize the environmental impact. So what it happens is that if it is circular manufacturing, that it means that you are utilizing the same resource for a longer period of time. You have more focus on reuse, you have more focus on remanufacturing and on recycling. So this helps into your global climate goals also, and it helps into green supply chains also. The last point, which is related to integration of emerging technology, you can see that everything we want now is smart. We want a smartphone, smart meter, smart mobility, smart building, smart factory, smart grid, smart devices. Overall setup, everything has to be smart when we talk about emerging technologies integration into our industrial setup. So these are the following six key technologies which are to be integrated: machine learning, AI, advanced algorithms, 5G communication, advanced blockchains, and smart additive manufacturing. Talking about machine learning, so machine learning, it helps into predictive maintenance of various machinery. It can anticipate equipment failure, it can schedule maintenance at the right time, and also it can reduce unnecessary downtime. And you have to create various machine learning models. So that depends on the objective or the approach of prediction. Like for example, it is remaining useful life model, or classification model, or anomaly detection model. So these are various type of models, basically regression model or historical model. These are basically to predict the failures by different approaches. And once you can predict the failure, you can plan your effective maintenance or timely maintenance for ensuring the high efficiency of your complete system. Then artificial intelligence, as we can see that it is very important that we take care of some of the critical issues, like we have efficient use of material. We should not have any dependency in terms of scrap, waste, production wastage should be avoided. Supply chain should be efficient. We should have very good distribution of energy sources. And so for all this thing, AI can support, AI can help. Basically, AI is nothing but it has got potential to fundamentally transform manufacturing industry by identifying that where we are losing. Where we are losing, identifying that area, and then definitely it is possible to take corrective action for that. 5G, all of us on our mobile phones, we have started using 5G now, and on larger scale in industrial setup also now 5G uses has started coming. It is much more efficient as compared to 4G or 4.5G type of network. You can have many more devices that you can connect with the same system. It is very high level of battery life can be achieved with this 5G, and bandwidth is also very high. And one very important area is that you can have your own private 5G networks, and these own 5G networks then can you do not have issues related to data disconnect or losing the connectivity anytime, because you have then your own spectrum, and your data is also secured there. Advanced blockchains, this is again to maintain the security of data, and also ensuring that your data is protected as per your requirement. So some of you would have heard about all this cryptocurrency and other things. So they are all based on blockchain only. So blockchain basically ensure that your data is protected, your information remains with you, your intellectual property remains with you, and cannot be shared by anyone else. Smart additive manufacturing, so Industry 4.0, a lot of work was being done on additive manufacturing, and as we have moved to now Industry 5.0, now smart additive manufacturing is merged now with integrated automation. And you see that earlier we were talking of 3D printing, now we are talking of 4D printing, 5D printing. So all that has got evolved with integration of this automation into additive manufacturing. So this is the building block. If you see here, starting from big data and analytics, then augmented reality, then autonomous robots or drones, then simulation, horizontal and vertical system integration, industrial Internet of Things, then you see cyber security, cloud and additive manufacturing. So these are some of the building blocks and architecture for Industry 5.0. Now, what are the challenges and mitigation for implementation of Industry 5.0? So, these are some of the challenges which are there while we are implementing Industry 5.0. So, legacy system entrenchment, workforce skill gap, that is another very critical area. Then siloed data and operations. So, this is in our industrial setup, it is a common thing that people want to work in their silos. People do not want to share their data knowledge within the complete setup, and the whole base of Industry 5.0 is based on sharing of data and information. Cyber security risk, which is another very critical area. There is a lot of resistance to change. Then capital investment is high, especially for the companies who are new in this area, and it also involves some level of supply chain complexity. So these are some of the areas. So legacy system, many factories, I would say today, majority of factories in India, if you will see, they are still relying on outdated machines and legacy control system. Just you see a simple example that if you are using a 10-year-old machine in your industrial setup, it will be running on Windows 6 or Windows 7. Now today Windows 7 is not supported. So any IT work you want to do or any automation you want to do, first of all you have to upgrade it to Windows 11 at least. Once you have to upgrade it to Windows 11, the cost involved will be very high. So this is one big blockage area, that if machines or factories they do not have latest equipments or machinery, it is very difficult to integrate AI or IoT or cobots with their system, because they will not support advanced analytics or AI or all those tools which are required for this setup. Skill gap, very important, because digital literacy, even though people, younger generation, they have become very good in using mobile and laptops, but still people working on machines, their knowledge level is very limited, and there is shortage of employees. In fact, very few universities in India, they offer subjects like robotics. Very few universities, and even if universities will offer, awareness amongst students is so limited that very few students will opt for courses like robotics. So the workforce that is available for handling such complex areas is very limited. Average age of employees. So today the age of employee, if it is between 20 to 25, their ability to adapt to these technologies is far better as compared to 30 plus aged employees. But if we see all our industries, we will find lot of employees 30 plus age. So that is another one challenge. And the last point, which is very important for all of you, that today whatever we are teaching and what is needed by industry, they are not matching. So we are teaching a lot of theory, whereas industry doesn't need theory, industry needs more of application of theory. So that is one important area which, because of which we feel there is skill gap in workforce. Then this is more of softer aspect that our way of working is always to store our data into isolation, whereas real-time decision making, it requires that all the data should be available so that best decisions can be taken. And because of this, even out of 10 functions, if one function is playing smart and is not sharing the data, then it generates a fragmented data that can lead to, in fact, sometime wrong decision can be taken, because AI doesn't understand that one of the function has not shared the right data. It will work based on the available data. So it can actually lead to some of the wrong decision making also. Cyber security, it is becoming reality now. We are seeing lot of cyber attacks. So basic examples, you read lot of cases that keep on coming, wherein people are getting attacked on their mobile. Cyber attacks are happening, but threat is much larger into industrial setup. Industrial setup threat is so large that if somebody who is very good into these areas, and if he this company should not produce, and if that company's system is completely integrated into IoT, he can bring the operation to halt if those systems are not safe from cyber security perspective. So cyber security is very important, and we have to ensure that while earlier we used to take it lightly from industry perspective, but last few years we have understood the importance of it, and a lot of investment, lot of money now we are investing into making our system safe and secure from cyber attacks perspective. Change management resistance, again one of the softer aspect. We have one mindset and we do not want to change our mindset, and this mindset issue is there both at leadership level and as well as at working level also. High capital investment, yes, this is an issue, and today a lot of small companies, they cannot afford, they have to see the return on investment. Sometimes return on investment can be longer, and if you do not have long-term vision, it may not sound useful to invest so much of money into all these technologies which are there. And all this cyber security and other things, the type of money, type of investment they are asking for, it is means for our size of organization, we are an organization of around 3 billion US dollar. Even we feel sometimes that what is happening, how much money we are spending into this type of cyber security things. Supply chain complexity, so it basically supply chain complexity, I would not say it increases, but it changes. So complexity changes from more of mechanical side to handling supply chain more onto automation side, or things like cobots and those type of things. So their complexity has to change. But at the same time, we have to accelerate the shift. We strongly feel at VCV that we have to make this migration. And so how we are working on is that we have developed a transformation roadmap. So we are not changing everything all of a sudden. We have started investing into some of the scalable and flexible technologies. We are working on upskilling the workforce. We have the software aspect of change management. So we are basically, what we are doing is, in many areas, we are creating people who can drive those changes in respective areas. So if it is driven through management, it is always difficult. But if it is driven by at peer level, it is always easy. So that is what we are trying to do. Data-driven culture, more reliance on data. Cyber security, as I shared, that we are focusing a lot on cyber security, and partnership. Everything cannot be done by us. So we are partnering with several agencies. We are partnering with academia. For example, IIT Indore, we are partnering with them very closely because they get a lot of students who want to work on industrial issues. and we need a lot of bright minds who can work on our problems. So that is one sort of partnership. There are a lot of startups who are there, uh, who have got good mind, but they do not get uh, any area where they can applicate. So we are collaborating with various startups also, and it is a win-win type of situation. If some idea clicks with the startup, we actually fund them. We actually even, for example, recently we have done a 50-50 joint venture with one of the company called Eicher. So as I shared in the beginning, that all our trucks and buses are 100% connected. Connected means all the data of trucks and buses we get. So if suppose today 1 million trucks and buses are running on the road with those connected devices, every movement, every second, I get data of those 1 million vehicles. And that 1 million vehicle data is processed every second. So like this complete on server, all this data is getting processed, through which we are generating data, value, knowledge. We are creating a lot of predictive diagnostic rules. We are creating a lot of future product development related knowledge. So all this keeps on happening. So there we have partnered with a company called Agrawal. We started working with them. They had good idea. They could develop a good concept, and then we invested into them, and we have 50-50 partnership with them, and now they have become quite big because of our support. How to adopt, and so this is one simple chart. You can see basically again the same thing which you saw earlier in slightly more detailed manner. So you understand the landscape where you are working, define your strategic objective, conduct a digital maturity assessment. This is very important aspect, that before you start blindly thinking that you migrate to industry 5.0 etc., it is very important that you assess your digital maturity, develop a roadmap, and then think of investment in infrastructure and technology, focus on workforce development, implement pilot project, scale and integrate, and then you monitor, optimize and further innovate. So this is the cycle which you can work. Some of the example at VCV, and this is the last part of my talk. So we are aligning Industry 5.0 with our sustainability goals, wherein we are fostering human-machine collaboration at scale. Lot of advanced automation with skilled workforce, and connected manufacturing for quality excellence, data-driven decisions for operational agility, and resilient supply chain with complete digital integration. So these are the things which we are driving. Some of the elements of smart manufacturing, you see sensors, system integration, automation, web application, virtual manufacturing, data science, cyber security, augmented reality, mobility app, all that what you saw earlier. So these are the various, you can see some of the examples through which we are using this. For example, on system integration, we use SAP, we use SCADA, we use MES. On automations, we have just started using cobots, but not in very high number, but robots, AGV, pick to light, machine interlocks, all these things are some example of automation. Lot of virtual manufacturing tools like Delmia, IDM, all this we use. Cyber security, as I shared, lot of focus we are giving now, and several mobile apps for handling various data, alerts, alarms, so all this we use. So these are some example. For example, in truck plant in Bhopal, so this is completely integrated CV plant. So all when I say integrated, even logistics, supply chain, energy, productivity, OE, cost, quality, safety. So all these tools are basically integrated, and it is complete. And this is the plant where we have actually started using some of the cobots. It is a complete green manufacturing plant with zero discharge and energy efficiency. Similarly, V powertrain, where we produce for Volvo, there also we are using a lot of tools related to IoT and AI analytics and integrated supply chain. So total till now we have had 277 IoT projects and 408 Pokayoke. These are all digital Pokayoke which we have worked out, and this is actually we measure that how these help us. So this helps us into enhancing our productivity. The another aspect on the sustainable. So today we are using 42% renewable power, and we have in-house rooftop solar plant. We have zero waste to landfill already. So 100% thinner is recycled. We have 100% of organic waste which is compost, and paint sludge. We paint all our cabins and cargo bodies. So all this paint sludge is again co-processed. 35% of flue gas exhaust heat. So we run a lot of trucks and buses. Exhaust gases come out. Similarly, all the furnaces that are burning, there again exhaust gases come out. 35% of it is getting reused either into energy heating or to run some of the energy devices. 65% of waste RO water, we are reusing it. All manufacturing facilities are green compliant. We have 100% clean energy for paint shop, and we do a lot of work on community development. For example, drivers, which is very big enabler for our industry. So 40,000 drivers we have trained, and we have donated 2 ambulances. So you can see that all plants are compliant for green building, and then we have clean energy, natural gas for heating applications, compressor heat recovery, flue gas exhaust heat recovery, 100% LED lights, RO water as I shared. So these are some of the, on right hand side you can see that these are our sustainable development goals for VECV. These are again some of the examples of work which we are doing for sustainable infrastructure, and if you see that this is my last slide before I go to conclusion. So because of which, because of uses of all this smart manufacturing, what we have gained, we have zero unsafe condition. So our quality is so good that we have less than 30 product demerit. We have got 40% reduction in our breakdown losses, 7% saving in manufacturing variable. We have highly flexible manufacturing which leads to 80% time reduction, and 100% skilled manpower are deployed, and definitely we have saved around 2400 ton of carbon dioxide because of sustainable levers. So to summarize and to tell you the way forward, I think first point which is very important is that this empowers people, drives resilience, customization, and this ensures sustainable and smart growth. People-centric innovation, this also helps into our workforce engagement once you are able to convince them that it helps. Initial part of convincing them is difficult, but once you convince, it is definitely going to help into their engagement. It boosts productivity and flexibility, reduces waste and emission, human-machine collaboration unlocks new value, strong partnerships accelerate co-innovation, continuous improvement ensures long-term success, data-driven insights enable better decision, and future-ready skills secure competitive advantage. So let's work towards empowering power people, enhancing sustainability, and shaping the future. So what we say on the end is that partnership is the new leadership. And why partnership is new leadership? Because complexity is increasing so much that you cannot do everything on your own. You have to partner. You have to partner with various people, academia, startups. You have to partner with various industries together. You will be surprised to know, I will give you two examples. Who are the top two truck manufacturers in the world? It is Volvo and Daimler. Mercedes-Benz and Volvo. They are the two largest commercial vehicle manufacturers in the world. So they have to be competitor because they hold number one and number two position. Now they have, in last 2 years, they have signed two joint ventures. The first joint venture is for development of fuel cells, hydrogen fuel cell. So Volvo and Daimler, they will work together. They will produce fuel cell that will be used by both of them. Now, last 2 months back, they have signed another joint venture. Its name is Cultura. It is for development of software-defined vehicles. Like we are today, we are talking of Industry 5.0 from product perspective. The future is software-defined vehicle, wherein all the vehicles will be run by software and very little means driver can be there on the vehicle, driver cannot be there on the vehicle, but still vehicle will run. It will run through softwares. So now on this software-defined vehicle, which is technology for the future, Volvo and Daimler, they have come together. They have signed a joint organization memorandum. So in 2030, whatever vehicle Volvo will produce or Daimler will produce, they will have common base. Why all this is happening? Because with increasing complexity, company of the stature of Volvo or Daimler, even they cannot think of working on their own. They are also looking at partnerships. So we cannot avoid partnership, and this is one very important tool to success in Industry 5.0, that you do not think of doing everything on your own. Do partner, work with various people so that your investment can reduce, your effort can reduce, and benefit can be there for all. So this was all what I wanted to share. If there are any questions, I can take up.
Sir, is there any government rules and regulations to imply the...
Sorry, yeah, continue please.
Sir, it is government rule and regulations as the challenges to
Adopt the?
adopt this point not 5.1.
No, there is no regulation.
But there is some compulsion, as you say, we are going to sustainability.
Sustainability is, sustainability is something, ESG is becoming a, I would say, for every industry it is becoming core. Today also, out of ESG, there is very little which is regulated. But from industry perspective, we have to be more alert towards what we are doing for the generation, current generation and future generation. So it is more of self-initiative. There are certain regulations, there are no regulation as such today on sustainability, but there are some guidelines defined by government that where industry should move to. And one of the very important areas is that every year we have to declare that what we are doing towards sustainability. So that is the only regulation per se you can talk about, but nothing specific on industry 5.0.
So as you come, we use 65% of RO, we use RO water.
So RO water, as you know, that we whenever we produce RO water, we are only utilizing 1/3 and 2/3 is getting waste. So we have some of the technologies through which this waste water we reuse. Just a minute, I will take one call and then.
can ask question to sir. He will answer your question.
Sir,
Yeah.
Industry 5.0 create more jobs or losses jobs due to automation?
It creates more jobs actually. It creates more jobs. Reason being that, see, you should not see more job or less job. Where are we today? We are at 4 trillion. We have potential of going to 20 trillion. So, Industry 5.0 we should see as a tool how to go from 4 trillion to 20 trillion. And if we move from 4 trillion to 20 trillion, what is your opinion? We generate more job or we lose more job? More job. We should always treat Industry 5.0 like this. It should be helpful for us.
So what is our involvement shifting from machine-driven system to human-centered model?
Sorry?
So what is our involvement?
What? Risk? Risk are
Our involvement shifting from machine-driven system to human-centered model.
I would not say risk, but I would not say risk, but these are the challenges. I would not say call them risk. They are more of challenges which are there from moving towards current system to more of human-centric system. So biggest out of this is getting adequate workforce who can handle this type of system, and second is our mindset change. Once we start thinking it as a positive way or positive method of progress, then it will become very easy. Adoption of this will become very easy. So that is the biggest challenge. Plus then additional challenges or risk are high investment, which is one very, I was trying to explain that unless you collaborate, unless you partner, it is very, very difficult to do all this investment on its own. Because this is a very complex integration. Human and machine integration is very complex. So once you have complexity, you need more money. ROI depends on, again, if you are producing, say, if you are producing 1 million worth of product today and you want to continue to produce 1 million with Industry 5.0, you will not have ROI. It depends on your vision. If you feel that today I am producing 1 million, 3 years down the line I want to produce 2 billion with efficient use of all this Industry 5.0, then you will get very good ROI. So that is where in one of the slides I shared that first you assess where you are, then you think where you want to reach, and there you see that whether deployment of these things are going to help you in terms of business case or not. You should not adopt all this blindly. Suppose if you are making a container box, you want to continue to make container box, why do you need all this Industry 5.0? But yes, if you have vision that today I am making only this type of container box, I want to produce 20 types of, 20 shapes of container box, I am today producing 1000 every day, I want to produce 100,000 every day. If you have that type of vision, then you deploy Industry 5.0.
Because my industries can use Industry 5.0 after they adopted technology, like MSME, small industries, startups, how can they use this technology?
So best way is that they should work in partnership with people, because with type of investment that is involved, it is not possible for them to do everything on their own. They should work in partnerships. Some part of it they can own, some part of it some other company can own, and all of them can together work on it.
I have a general segment. Actually, as you mark, Eicher is one of the leading, you mark Eicher is the leading organization at the global level. And there is a gap between the academia and industry. So, what type of services Eicher may offer for the technical institutes? Because there are nomination from the 15 technical institute here. some of the MATs also, because we are also part of MATs, ITM also, IPS also, Shriram also, from several universities and colleges the participants are. So how can they be associated with the Eicher for restaurant development, for their own development, because maximum are the MTech graduates, MTech postgraduates, and they are interested to pursue a PhD in the same sector.
We are fully open. We can discuss on various. There can be various ways. We can arrange for some of the visits to our facilities. We can, for smaller groups, we can arrange some of the training sessions wherein we can hands-on explain that how these technologies are actually used in industry. If some of the institutes, if they have got certain level of setup where they are at that stage where they can collaborate with us in some of the development, we are open to that also. I just explained during my talk that we are collaborating now with IIT Indore on some of the developments related to, it is one specific area of EMI and EMC, electromagnetic interface. So the interference, so there we are facing a lot of challenges on this type of integration. So in that particular area we are collaborating with IIT Indore. So it will all depend on what type of competence, facilities you have got, what type of need we have got, then we can collaborate. Otherwise also, if you just want to get some training, knowledge, industry visit, we are open to that, we can definitely support.
Thank you very much, sir, for an exemplary session on future trends and hurdles we must tackle in implementing Industry 5.0. Your deep insights and real-world examples have given us a sharper and more realistic roadmap for driving Industry 5.0 solutions forward. We truly appreciate your time and expertise. May I now request respected VC sir and the coordinator of this faculty development program to present a token of gratitude, a memento to our guests. Sir, please come on forward on stage. Thank you so much, sir, for your expertise and valuable insights shared with us. Now it's time for a high tea break. Please enjoy.